Okay, we're going to find a tracker software to run on a computer. Now this won't run on a Chromebook because it's for Windows, Mac, or Linux, but you can load this to your device at home to just get the data real quick into a spreadsheet. So let me show you how this works. So after you download the software and install it, it looks like this. And what's really neat about this software is it allows you to grab a video, let's say, that you've made. So let me show you one that I just imported. And basically you can import that video into the lab tracking software. So give it a second while it loads. This is about a 13-second video, but it still requires about 30 seconds to install it here. There's a little warning perhaps. You can say don't show this again, I think. You're going to want to trim your video. So in this particular video, you'll notice that I've made this in my classroom, and you'll see that basically I'm going to just run across the screen. So in a simple experiment, I'm going to run across the screen. Okay, so I actually end up later running back the other way, but I don't need that part of the video. So I'm going to go ahead and grab this little black handle. I'm going to trim it all the way back to right about here, right where I finished my run. So it's about frame 135. And then I'll grab this start frame handle here in black and drag that over until when I actually see myself running. So I don't need to have, this introductory time where I'm pushing the button and getting set up to run and all that. So I'm really only going from frame 83 to frame 135, okay? All right, so now what you want to do is go here to show or hide the coordinate axes. So you go like this, and you can grab it from the middle with your mouse, and you can move this down. So I'll just line it up with the edge of my whiteboard there. And also, I'm kind of interested in just part of this screen. So I'm just going to, you see where the whiteboards meet here with the metal strip. I'm just going to put the origin of my axes there. I'm going to run the positive x-axis along the marker tray of my whiteboard there, okay? All right, so now I'm going to put in a point. Right here, there's a thing here called Show, Hide, or Create Calibration Tools. That's in case you want more rulers and things. But right here, there's a button called Create, and I'm going to choose Point Mass. And that point mass, I'm going to kind of just use this as my first frame, maybe frame, let's see here. You can also advance through the frames carefully like this. So I want to show me running, but I want to be kind of near where this trash can is for my first running frame. Okay, so see where I entered the screen here? It all happens so fast, but you want to kind of capture a good starting moment. So you don't want to pick like an arm that's moving or something. You want to pick like a part of the body that stays relatively stiff. So maybe like my center mass near my mid-thoracic cavity or abdominal cavity here in this area. So maybe like right around maybe here. And what you want to do here is hold down the shift button. You see how it says shift click to mark. You have to hold the shift button and maybe just kind of click right on the pink line, maybe like right where my belly button might go. Okay, it's going to automatically advance the frame, and I'm going to try to capture that same spot on my body again. So on the pink line and belly button. And as it advances, you can see, I'm just going to keep on doing this. So keep clicking that belly button, try to stay on the pink line like this. Okay, so this is a really nice way to capture the motion because I don't have to actually set up rulers in the classroom or stopwatches. Because the video already has a timestamp built into each frame, I can just simply use those existing frames and capture the time data. Okay, I think that's far enough. I've already gone past the x=0 mark. So I have over here this table that formed automatically, and you can see also over here that mass A has been moving a very particular x over a very particular t. So this is a graph of not all three columns, but t versus, or x versus t. So you can see that my x's are decreasing. That's because I'm running from right to left. And my don't look at the red numbers. Those are just indicators of which point in the table we were talking about. But let's say you go back here and you click on the 22. It'll highlight. Oops, I tilted my axes. If that happens, just go ahead and go in this box right here and type 180 again. Okay, I was going to click on this 22 right here if I can. Let's see if I can do it without grabbing the axis. Yeah, so I clicked on 22 and it shows this first point of interest. At that time, here's my X, here's my time. I can also click on the 23 here, and then that jumps down to the next line in the table. So you'll notice the Y's are all pretty much the same. See that? They're all about -3.5. I'm really not interested in that column anyway. So if you want to, you might find a way to delete that column. But the table matches the data for X and T. You'll see there's no Y in this table, in this graph here. All right. Now, aside from some units issues, we basically have then our data here. So something tells me that I might need to work out some units, and what exactly are these meters? I don't think I really did run 200 meters in this 0.606 seconds, you see. So aside from that, though, we have some relative data that we can grab here and we can put into an Excel or a Google Sheets spreadsheet. All right, and there you have a quick way to capture an experiment. I just used my phone to videotape this. I downloaded it from my Photos app to my hard drive. If you're an Apple Photos user, you could do that, or if you're a Google Photos user, you could do it that way. Okay, so I'll go ahead and go over how to change the units now. So if you click on coordinate system units, you can see that the lengths are measured in meters. Masses are measured in kilograms, and time is measured in seconds. That's perfect because we use the MKS ampere system in physics these days. Also, for angles, this is nice. You can choose between radians and degrees, so that's wonderful. Since we probably won't be changing these units, just leave them the way they are. But we might want to use radians here and there. Now, what's really nice is I can go here and create what's called a calibration stick. So you see here, you can click on this point, this creation thing, and you can go to calibration stick or calibration table or anything you want. But I'm going to go to here and I'm going to basically pick an object that I can easily measure right here, right now in my classroom. So how about I measure, just for calibration purposes, I'm going to measure, let's see, something that's easy to find in the picture, something near my line of interest. Let me move my video running character off the screen there. Okay, so I'm going to actually measure the bottom of my whiteboard. And so I've chosen calibration stick. Again, I have to use shift click. I'm going to click this corner of my whiteboard and this corner right under that metal strip there. And it says 0.908 meters. That's not even true. I'm going to go right now to the front of my classroom. I'm going to measure that thing with my meter stick. Okay, I've walked away from my computer. Can you still hear me? You can't see me right now because I'm not filming, but I'm measuring that exact same part of that blue stick there. I'm actually measuring it in real world measurements here. So I have a yard stick, but I can convert yards to meters easily enough. So let's see here, I'm measuring 2 yards, let's see, okay, 2 yards and 2 feet, 2 yards and 2 feet, so that would be 8 feet, and that makes sense. This is an 8-foot whiteboard. That makes a lot of sense. Okay, feet's no good, so you can convert that real quick to meters. So you can just basically ask Siri or Google how many meters is 8 feet. So that's what I'm going to do now. So it's 2.438. You can also get that by doing 8 divided by 3. Let me show what I'm typing here. 8 divided by 3.281. Okay, so it's 2.43 roughly meters, and more accurately, Google says 8 feet in meters is hold on. Yeah, it's 2.438. So the extra 2 there, who knows? So let's just not worry about it. We'll just do 2.438 meters. Now, what's my error on that measure? That's pretty easy. My meter stick is measured in basically 1/16 of an inch. So since it's measured in 1/16 of an inch, no, I take it back. My meter stick's measured in 1/8 of an inch. That means I can only trust it by 1/16 of an inch. So 1/16 of an inch, though, is a very small measure compared to 8 feet. So 1/16. It's only basically a 0.7% error. Or what I should say is it's only 0.7% of the full length is my error, very, very small. And also, if you convert 1/16 inches, you basically would find that's very, very few meters. So it's not a significant thing to concern yourself with, but you would need to report it in your errors if you're doing a report. Yeah, so 1/16 of an inch is only 0.0016 meters. And that, compared to a full 2.38 meters, is even less. It's a very insignificant, small amount. So that would need to be reported, of course. But what this did, if you'll notice, is it updated my table already. See, so my table is already now measured in real life world units. And you might see these 7s over here. That's -7 times 10 to the minus 3. So it's basically -0.007. Which is comparable to 0 or -1 even. So, or -0.1. Don't take these y's too literally. You kind of know they're already positioned along the x-axis. I've hidden the points, by the way, so you can't see them, but you saw them here just a moment ago. All right. Now you have your data. Grab it and go. I've also looked into how to use the Chromebooks to do this. There is an app called Lab Camera. However, it is not accessible through the school Google accounts. So these apps are becoming more available, but it seems to me that a PC or a Mac might be the better option in this situation where we are using this video analysis. The Chrome apps that I have found cost money, usually around $15. And from what I've read, some of them are a little bit unreliable.